This puzzle is called Irregular 4x4 Thermo Arrow Sud by TopAutism. I didn't see this before. The rules are, you're so great at 4x4 Sudoku. Congrats. Okay, let me see. Look at the post and look at the rules. Okay, so we have, first of all, irregular 4x4s. So instead of 2x2 regions, we have these differently shaped regions. You can tell the regions by the bold outline, and um, each region will be a set of the digits 1 to 4 with no repeats. So instead of the 2x2, these two could repeat, but this has to be a set of 1, 2, 3, 4, as does this. Whoops. And still, only each row and each column are also a set of 1 to 4. Um, then we have an arrow sum here. So these two digits are going to sum up to this digit. So if this was 1 and 1, this could be 2. If this was 2 and 1, this would be 3, and so on. And that's how arrow Sudoku works. And then we have a thermometer, and digits increase along the thermometer as they get farther away from the circles. So if this was a 2, this would have to be greater than 2. If we discovered that this one up here was a 3, this would have to be less than a 3, and so on. Probably not too hard overall, maybe a little tricky. I'll put a link down in the description if you want to give it a try. And let's get started. So my first thought is that this is going to be a coloring puzzle, but I'm not 100% sure on that. Let's try coloring a little bit. So where can this green cell go up here in this kind of Tetris-shaped region? It can't go here because that would be the same column, of course. It can't go here because the thermometer means that this digit is going to be greater than this digit, and of course a digit can't be greater than itself, so green is going to be in one of those two. Now where can green go in this region? Well, it can't go here or here because that would be the same row or column as the original green. It can't go here because that would be the same row as the pencil marked greens we just did, and then this will be green as well, and then one of those two. I don't see a way to differentiate quite yet, but that's at least a first step. Okay, so the next color we can go is here. Where can this digit go in this region? Well, it can't go in the same row, of course, so it must go over here. And then it must go over in one of those two spots in this top region, and same with over here. Maybe coloring isn't the way to go. Oh no, I think it is the way to go actually. So where can this digit go in this top region? So it can't go here, it can't go here. So it's going to go in here. But now we have blue and greens locked into the exact same two cells in this region. So if we try to make this red, where's blue going to go? Well, blue has one option left, so we make this blue. But now where can green go? Green can't go in either of these two, and now green can't go anywhere. So the puzzle's broken. Another way to phrase that is, or another way to just, say that is that this must be a blue-green pair. This can't be any other colors. It must just be blue and green. Because otherwise, there just won't be space for, like, those are the only two spots for those two colors. They both must be those colors then. So that leaves this as red, which means it is red, which means this isn't red, and makes this red, which is going to make this green, make this not green, and then make this green again. Which then makes this blue, because this is the last cell in the region that could be blue, because this one rules out there. That makes that blue. And then we can color the remaining options like this, and that works just fine. Okay, so we have two different digits adding up to something. So that could be, this could be a 1-2 pair adding up to 3, or it could be a 1-3 pair adding up to 4. That seems to work to me. But one of these has to be a 1. If they have to be two different digits, we can't do like 2 and 3. We have to include a 1 as one of these two different digits. But we know that purple isn't. Sorry about that. Hopefully I can cut that out. Had an interruption. Where was I? So red or purple must be 1 because 2 plus 3 would be 5, which would be too big, right? So we must have a 1. But over here in the thermometer, it says that purple is greater than something, right? So if we made purple 1, then this would be a 1, and then what would green be? Well, I guess it would be a 0, but that's not possible here. So purple can't be a 1, which means that red must be 1. Okay, so now we have purple as 2 or 3, and it's greater than 3. Sorry, it's greater than green. So what's possible here? Well, if we made purple a 2, then green would be a 1, because that's the only digit greater than, or sorry, less than a 2. But we've already made red 1, sorry. Red 1, for whatever reason, is a tongue twister for me today, I guess. So if we made purple a 2, this would have to be a 1, but that would break the puzzle. So that's not actually possible. So purple must be a 3, green must be a 2, and then blue must be a 4. There we go. Not too difficult. Yeah, not too difficult, but nice little brain teaser. A little bit harder than some of the other ones. Slightly harder, I guess. And if you completed it correctly, you see in the rules you are so good at 4x4 Sudoku. Congrats. So there you go. Thank you for watching, and thank you to TopAutism for the puzzle.